Hello, mathematicians. Today we are learning about the difference between theoretical probability and experimental probability. So theoretical probability is exactly like what you guys learned yesterday, which is basic probability, which is the chance of an event occurring. So theoretical probability is what should happen during an event. Now, today we're introducing experimental probability, which is what actually did happen during an event. So if we have an experiment, like a graph or a table, then we're going to use experimental probability with that. So our first example, the graph shows the results of spinning a spinner 60 times. So when we spun it 60 times, we got 21 times were green, 15 times were blue, and 24 times were red. First, it says find the theoretical probability of spinning red. So this is what should happen. So for theoretical probability, we're not even going to look at the graph. We're just going to focus on what should happen. If we spun it 60 times and we have three colors, same outcomes, green, blue, or red, then how many of those times should we get be red? Well, if we have three colors and we're spinning it 1/3 of the times, it should be red. What is 1/3 as a percent? As a percent, 1/3 should be 33%. So this is our theoretical probability. This is what should happen. Now, number 2, find the experimental probability of spinning red. So what's experimental probability? What actually did happen? So this time we are going to look at these bars on the graph. So how many times did we spin red? 24 times. How many times total did we spin the spinner? 60 times. So our probability is 24 over 60, but first we need to reduce that. So when we reduce it, we should get 2 over 5. Now go ahead and change that to a percent. All right, so as a percent, 2 over 5 is the same as 40%. So our experimental probability of spinning red is 40%. All right, our next example, a number cube or a dice is rolled 30 times. The results are shown in this table. So on the left we have the number on the dice, and on the right we have the number of times that number was rolled. So number 1, find the theoretical probability of rolling a 5. So we need to remember theoretical probability is what should happen during an event. So go ahead and try the first one on your own. All right, so let's see what you got. So we're finding the theoretical probability of rolling a 5. So we have 6 options on our cube. We can have a 1, 2, 3, 4, 5, or 6. So rolling a 5 is only one of those options. So our probability is going to be 1/6. Go ahead and find that as a percent. As a percent, 1/6 should be, that's about 0.17, which is the same as 17%. Number 2, find the experimental probability of rolling a 5. So remember, experimental probability is what did happen. So go ahead and try this one on your own. Alrighty, let's see what you got. So we're finding the experimental probability of rolling a 5. So for this, we want to look at our table. So we know that we rolled the dice 30 times. And now we want to look at how many times a 5 was rolled. So we rolled the 5 4 times. 4 over 30. So we need to reduce this down. If we divide by 2, that'll give us 2 over 15, which is approximately 0.13. And then we can change it to a percent, which is 13%. So the experimental probability of rolling a 5 is 13%. For our last example, a store sold 2,000 DVDs 300 of them were scary movies. Find the probability of randomly buying a scary movie. So, this is just going to be like what you guys did yesterday, finding basic probability. So, what was the number of outcomes that could occur for scary movies? 300. What was the total number of outcomes that could occur? 2,000. All right, so when we reduce that down, we get 3 over 20, which is 0.15 or 15%. All right, for number 2, if they expect to sell 3,000 DVDs this year, how many scary movies should they have? So this is going to be exactly like what you guys were doing a few weeks ago with proportions. So we're going to start with what they had before to what they have now. So we're going to start with what we had from our last problem, which was 3 over 20, because that's the probability of getting a scary movie. And then we can say that is equal to, well, we don't know how many scary movies they're going to sell now, but we know the total number is going to be 3,000. So on top we had scary movies, on bottom we have total number of DVDs. So when we have proportions like this and we need to solve for x, we can cross multiply. So then we get 20x equals 9,000. All right, so now I want to get this x by itself. So I need to divide by 20. And what I do to one side, I must do to the other. So I'm going to divide by 20 on both sides. And then I'm going to get that x equals 450 scary movies. Nice job, mathematicians.